This is a simplified geological map of the main Ordovician sequence in West Shropshire, and I'm currently here on Stanley Hill. At first glance this map looks pretty complex, but what I'm going to do over this episode is break it down and go through this sequence layer by layer to show what the Ordovician rocks in Shropshire tell us about the past. So the Ordovician period covers over 41 million years, from about 485 to about 443 million years ago. And during that time there was no life on land, but there was an abundance of biodiversity within the oceans. So what was going on in Shropshire in this time? Well, the Ordovician rocks in Shropshire occur in three locations. There's a small outcrop west of Oswestry, there's east of Church Stretton, and here in West Shropshire, centred around the hamlet of Shelve. All the rock layers tell a similar story, and in the Shelve area the sequence is most intact. Well, we've got a series of rock layers that are tilted at an incline away from Shelve, which form the centre of an anticline. And this anticline formed during the early stages of the Caledonian orogeny, when Avalonia collided with Baltica near the end of the Ordovician period. A major part of this is the Welsh Borderland fault system. Now this is a series of faults running through southern and central Wales and into Shropshire, and two key branches within Shropshire are the Ponsford-Lindley fault and the Church Stretton fault. As movement during along this fault system that resulted in the land dropping away to the northwest, allowing Ordovician sediments to be deposited over much of northwest Wales and parts of Shropshire. These layers then got folded in the shelving event at the early stage of the Caledonian orogeny, prior to the Silurian sediments being deposited up on top of them. And what it means is, because of this angle, we've got multiple layers from the Ordovician period visible, and these are the what show up on the geological map. Now, these layers get progressively older as you travel from the west to the east, the youngest being the Whittery Shale, the Whittery Volcanics, Hagley Shale, the Hagley Volcanics, the oldest shale, moving on into the Spywood Sandstone, which is this little low rise on the other side of the small stream, which then goes into the Rowington Shale and the Meadowtown Shale. And then this rises up again into the Western Flagstones, Stapley Volcanic Formation, which is mostly lava and tuff. The Hope Valley Shale, it's about 461 to 466 million years ago, is the Hessington volcanic member. Now it's predominantly felsic tuff and tuffite, so there's a little bit of andesite in there as well. And the Hope Shale in the valley in front of me, the Stiper Stones quartzite, and then the Shinnerton Shale being the oldest at the base of the Ordovician. Now the Stiper Stone quartzite forms the Stiper Stone Ridge with its dramatic frost-shattered tors. Now it's not actually quartzite, as the rock is sedimentary, not metamorphic. The formation is actually a very hard white sandstone that was deposited in a beach environment. Now the observant amongst you might have noticed that I mentioned volcanics in the list. England and Wales at the time were part of the small continent of Avalonia and near a subduction zone as the Iaptus Ocean was closing. Scotland was part of the continent called Laurentia, further to the north. Now what was happening to the Iaptus is similar to what's happening with the Pacific Ocean. The ocean is closing. So what we've got is tectonic plates being subducted underneath the continental plate, and this subducted molten rock making its way up to the surface to form these volcanic layers. Now in Shropshire these are deposited predominantly as layers of lava and tuff, and these form these volcanic layers in between the sediments. So what would happen is we've got layers of mudstone and sandstone being laid down in between periods of intense volcanic activity, layers of lava, layers of ash getting deposited, and then the regular sedimentary layers continue again. Being more resistant to erosion, these volcanic layers form a series of hills and ridges, whilst the softer shells and mudstones eroded to form the valleys in this part of Shropshire. As a side note, it's in these Ordovician layers, particularly the Mifflin flags, that we find Shropshire's mineral wealth, particularly lead, barite and occasional traces of silver. This was this mineral wealth that I alluded to in the episode of the Anthropocene, with human activity mining in the Stuyvesant area. Now, you do occasionally find fossils within the sedimentary deposits of the Ordovician in Shropshire, and I got lucky and found some graptolites in the Wittery Shale, just giving an example of some of the biodiversity that was in these ancient oceans. So what the rocks of Shropshire tell us is that during the Ordovician period we've got an environment that's in constant change. We've got the edge of a continent that is moving northwards. We've got a subduction zone pumping out volcanic material, and we've got the regular, everyday sedimentary deposits being made on the continental shelf and just offshore. And it's these rock layers that give us the fantastic ridges and dales landscape of Western Shropshire.